Hello, good morning. Hope everyone is doing well. So this is Managerial Economic class. We are in tutorial number 4, demand estimation. We have set of data for almost 500 retail store for a particular product X, and we are going to use this data to estimate the demand function for that product and also some elasticities. So here are the things that we are going to discuss. So first we try linear regression, insert whether variables you want and use the descriptive statistic to decide if you have a good fit, what are the interpretation of your coefficient. And also we tried experimenting with logs, the same model but with log. Take the natural log of some of or all of the variable and run the linear regression. And also we can also calculate some of the elasticities: on price elasticity, cross elasticity, and income elasticity, maybe advertising elasticity. So this data is here, table 4.1, and you can see we have the quantity, the price of that product, the income or average income of the customer to visit that store, the average age of the customer who visit that store, if the store visited by mostly by male or female, if the store is located in urban area or area, how much or the average advertisement spent on the particular product for each store, and also the price related for the related good could be substitute or complement. After we will check based on the analysis. So we go for views. We start new work file. Here views have three choices or categories. The first is unstructured and dated, and this is where we have, in our case, only one period of time, but we have so many observation, or we have so many number of stores. And second, we have dated or regularly frequency, when we have only one case. Could be country, could be company, could be store, could be person, but we have data for many or various period of time. Could be annual, yearly, monthly, weekly, quarterly, daily. And the last, a combination between two, which is a balanced panel data, where we have cross-section and time series. So we combine both of them. So in our case, I'm going to choose this undated. I have 500 observation. I put OK. So now I'm going to import the data. Importing the data, there is two ways. Either I will come here, file, import, and choose where is my file. Should be here. Yeah. Okay, I need to close the file, I think. Not save. Try again. Oh. Start over. Okay. File, import. Okay, so next, finish. Okay, so all the data is important. Sometimes we have, as we see just now, some problems in imported data, we can do it in different way. Let me close this. I don't want to save. I put it again. Open. Book file. 500. And I import the data in this way. Quick. Empty. Group. This. Edit series. I make sure that I put the first case here where there is no number. So now I go to my file. Waiting the file to open. Okay, so I don't need the return number, so I come from here, quantity, and write. So from quantity, something wrong with the mouse. Okay, Control C. I go back to my eViews and put Control V. So all the data is here. So here I need to close it. You want to keep, name it or no, it's up to you. So now we assume that the quantity is a function of price related income, advertising, urban, age, for example. So how now we are going to estimate this? So either we come here, quick estimate equation, and we write here quantity, then space C, which is the beta 0, then I put all this price related income, advertising, urban, and age, and put this the least square. Okay, so we will have it. But sometimes the model is very complicated, it's very huge, and also the names are very complicated, so it will take for us a long time to write all this. So what we can do is we do another way. So I close this, delete equation. Yes, so since the dependent variable is quantity, I click for it on it first. If you understand, the first variable is a dependent variable. Then after I put control and I put the other price. Okay, price related. Then we have income. Then we have advertising. Then we have urban. Then we have age. So right click, open as equation, and it's already written here. I just press OK. I have my equation. First thing that I have to look is here, the F statistic. This probability of F statistic must be less than 0.05, or otherwise our model will be insignificant. So we must make sure that the model is significant, otherwise it does not make sense. We have to correct our model. So we can see here the R square equal to 0.7173 means that the 71 or almost 72% of the quantity is explained by price related income, advertising, urban, and age. So now interpret this result unless we make sure that our model is free of biasness, or we call those multicollinearity, heteroscedasticity, serial correlation. It is normally distributed, and also the model is correct. First we start with multicollinearity. Multicollinearity means that we should make sure that our independent variables are not correlated among each other. So here we are going to put or to assign each of independent variable as dependent variable. So I put price is the equation of price related, income, advertising, urban, age, and count how much, calculate how much, the VIF. Then I put price related as dependent variable and price, income, advertising, urban, and age as independent variable. We can see we don't consider here the quantity because it's dependent variable. It must be correlated with independent variable. So we are just dealing with only independent variable. So VIF, after we calculate the VIF equal to 1 divided by 1 minus R square. Okay, so how we are going to get now R square for each one? As I say, I will close this, I put it as equation 1, and I go, since I'm going to count for first one is the price, I will click first on it as dependent variable, then I will click the others. For example, advertising, age, income, price related, and urban. So quantity I will not click on it because it's dependent variable. Right click, open as equation. Okay, so you can see R square is 0.013437. so this equal 1 divided by 1 minus 0.13, sorry, 0.13 437, and equal around, if I'm mistaken, let me see calculator, 1.0136. So if we found the VIF less than 5, that means the multicollinearity is not serious and we can continue. If the VIF is more than 5, that means we have a very serious problem of multicollinearity. We have to solve it. I'm not going to talk so much about this, but one of the things that we do is to omit this variable. But sometimes the variable is very important, we cannot omit it. Then we have to find a way, either we increase the series or number of observation, or maybe if it doesn't work, we will give a proxy for that variable, or we give another measurement if possible or applicable. So if all these things that you have done but you cannot solve it, then you have left with no choice but to omit the variable. So I will not go into count for every variable VIF, but I assume all of them have VIF less than 5. So now after doing that, I will close it. This I don't need it. So now I will come back to my equation, first one, and now I will check for serial correlation and hetero problem and diagnostic test of the stability test. So I start with the hetero problem. So as I say, we go first for the hetero problem and how we detect it. So I go to here, view, then residual diagnostic, then you can see here heteroscedasticity test. So I choose arc, put OK. Okay. So here, as we can see, the chi-square, or the probability of chi-square, is above 0.05. So we have the null hypothesis. There is no heteroscedasticity problem, and H1 there is hetero problem. Therefore, I am going to accept I cannot reject the null hypothesis, and I have to accept it. So H0 is there is no hetero problem. So in that case, I don't have a problem of hetero. But let's say if we have the problem of hetero, we assume that P is equal to 0.03, which is less than 0.05. So in that case, I am going to do a remedy for it. So I will come here, estimate, option, and here I will click this Huber-White test and click OK. So in that way, I'm going to solve the problem and continue from here. But since I don't have the hetero problem, so I go back and put it as ordinary. Since I don't have hetero, now I will check for the serial. Serial correlation again, view, residual diagnostic, I put LM, serial correlation LM test. Okay, again here, you can see, we have also H0, or the null hypothesis. There is no autocorrelation problem. H1, there is autocorrelation problem. Since my p-value is greater than 0.05, I cannot reject the H0, I have to accept it. Accepting H0 means there is no autocorrelation or no serial correlation, which is good. But if, let's say, we assume that there is serial correlation, then again I will do the same, estimate, option, ordinary, I put New Way West test, and I put OK. And in this case, my serial correlation problem is solved. So I return back since I do not have the problem of serial correlation, so I put it ordinary again. Then after that, we go for to check the normality test. View, residual diagnostic, and we put this is histogram normality test, and we will have that here the probability also it is above 0.05, which is 0.059. So what is the null hypothesis? Null hypothesis, error term normally distributed, and H1 error term is not normally distributed. Since my probability or p-value is greater than 0.05, means that I cannot reject the H0 and I have to accept it. So H0 means error term normally distributed, therefore you see, yes, true, you can see our graph, the data is normally distributed. Then the last one will be checking for the model specification. View, then here I go stability diagnostic and click on reset, Ramsey reset. So I put OK, and you can see here how much the probability is above 0.005. So we are going to accept H0, cannot reject it. What is the H0? H0 is the model specification is correct. H1, the model specification is incorrect. Since our probability is above 0.05, then we are going to reject to accept H0. The model specification is correct. If the model specification is not correct, then you have to go and put some adjustment on your model again. One of the now I still have another one test for stability. View stability diagnostic and come recursive estimates, and I put custom test, and you can see this blue line should not pass or go beyond the red one. So my data is, or my model is stable. Again for the second, now this custom of square test, and you can see also the line or the blue line is between the red lines, so it is not over. If it is over, that means there is problem with that particular period. So since all the data is correctly, there is no problem of the diagnostic test, then I repeat back to estimate and put OK. So will be, this is the original model and it is the final model, is nothing is changed here. Now we can interpret our result. So I can say that price is significant and the coefficient is minus. It must be, because the relation between price and quantity is negative. If the price increase, quantity decrease. If price decrease, quantity increase. If I found here the sign is positive, that means my model is totally wrong. It doesn't make sense. So how to interpret now this? I will say 1 unit increase of price, that means the unit here is 1 ringgit, lead to the quantity to decrease by 7.43 units, which is significant. But for related price related, it is minus, but again it is not significant. What does it minus? If the price of related good increase, the quantity of the good X will decrease. So by right it is complement. It is like sugar and coffee. If the price of sugar increase, the quantity of coffee will decrease. People will consume less coffee because maybe they can't afford to buy very high expensive sugar. So signs negative, that means this good is complement. But again, you see here the coefficient is not significant. Income increase, and this shows that the good is normal and the sign is positive. If the sign is negative, that means the good is inferior. But here, since income increase, 1 unit of income increase, 1000 maybe ringgit, lead to the quantity demanded to increase by 3.4 units. Advertising or advertisement is not significant, and also the impact is very minimal, and the coefficient is not significant. So means that maybe the shops is spending money at advertisement, but actually there is no increase in sales. Again, urban means sign is negative, but also it is not significant. Means that if the person live in urban, then particularly that particular good, or the demand for that particular good will be decreased. If the shop is in a rural area, then the demand for that particular good will increase. Age is significant and it is minus, means that 1 unit decrease in age, or 1 unit increase in age, 1 year increase, lead the quantity demanded to decrease by 2.6 units. Means that younger people are usually buying this good rather than elder people. But you can see here we talk about units, and if you want to count the elasticity, it's a little bit difficult. So in order to make it more easier for us, I'm going to transfer all these to a log. Then instead to explain by the unit, using the unit, I will explain using the percentage. So those who are not significant, I will drop them, like price, like advertising, and urban. So our new model will be like that: urban remove, advertising remove. So we will have price related no, income, price, income, and age. These three variables that shows that they have really a significant impact. So what I will do, I will transfer now each one of them to a log. So I will write this function here, ln, that's mean log quantity equal to log quantity between bracket ln. Then I also have ln price equal log price, and ln income equal to log income, and ln age equal to log age. So how to do that? I put here suppose there is one here, generate. Where is it? I have one option here is missing. Okay, I close this. Yeah, here. So generate, and I put the first one. So ln quantity equal to log quantity, and you can see here it's already generated. Then again generate ln price equal log price. Then another one, generate ln income equal log income, and the last ln generate ln age equal log age. So now I do my equation. So will be ln quantity first, then control ln price, then ln income, then ln age. Right click, open as equation. Okay, and you can see all of the variables are significant, probability also significant, r square is 63 still also, but here our r square power reduced. Now this we have the quantity 65 of the dependent variable or quantity demanded is explained by price, income, and age. So first, when we include the other variables, we have almost 73, right? Now we have only 65, but still good model. So now how to interpret that? I'm not going to do again. Suppose we do again serial correlation, hetero problem, normality test, but I'm not going to do that. So I'm just going to now explain this. Now we have the price also must be a negative sign. So I can say now 1% increase in price lead the quantity demanded to decrease by 0.64%. So almost half, which is easier, right? And it's significant. And I say that 1% increase in income lead quantity demanded to increase by 0.43%. And 1% increase in age lead the quantity demanded to decrease by 0.41%. So it is very easy to calculate. Now again, how now we are going to know what is the own price elasticity? If you remember, in our class we already discussed that the price elasticity of a logarithm coefficient is the coefficient of that particular. So we have own price elasticity, this the coefficient is minus 0.64, so the elasticity means that equal to minus 0.64, which is inelastic because E in absolute value is less than 1. Income elasticity is less than above than 0, positive, so this good is normal. So elasticity of income equal to the coefficient of income, which is 0.437. And for age, I don't think that we have to calculate elasticity for age. But if you want to calculate for elasticity for advertisement, then we have to include it in the model here also. For example, maybe let's include it in the model. Let's close this. Okay, and let's generate LN advertising. LN advertising equal log advertising. And what also we omit, I think urban now need because include 0, so we don't need to do it. So here I include advertising. Open as equation. Okay, then it's not significant, but also we can see the coefficient is very low, and the elasticity is 0.01, almost 0. So that it doesn't have an impact. So changes for elasticity to changes to the quantity demanded is very small. You spend a lot of money on advertisement, you maybe increase only a little bit. You spend 100% increase of advertisement, correct? You add only 1% increase of quantity, which is too much small, so that is not significant. So with that, I think I have explained how you estimate your demand for a particular good and your elasticities. I will see you in the next video, inshallah. Thank you very much.